Hi, and welcome back to this thing I very obviously haven't come up with a name for yet. Um, it's been about 2 months since the last video, and a lot has happened in that time. I moved to a new place and had an interesting business trip and other stuff like that. But I've been dying to make a video for a while now, so I figured might as well just start recording and come up with something. So a couple of nights ago, I had a really weird idea for how to do transparency. So if you look at the desktop picture I have, wait, okay, sure, let's deny that. Um, there's glass existing, which is a specific material that does refraction and stuff. But this is kind of a different type of transparency. I don't want it to be glass. It's sort of a higher level thing. So basically, if we have like a plane with a texture that has an alpha channel, like a PNG, we want to handle that alpha channel basically. So thus far, I haven't even looked at that channel. So we're gonna try and kind of add something. This is probably not correct. It's a bit of a hack, I think, but I think we might be able to make something happen. So the idea is that we can have like a test scene with like a plane with a texture on it that has an alpha channel that we can then see through when it's transparent, obviously. So I'm not gonna try and do any kind of color mixing. I'm just gonna kind of Monte Carlo it, so do like a statistical thing. So I'll show you what I mean. So first we need a test image. So I'll just grab one. Test PNG. Hopefully these are all good to use. What should we use? I don't know. Is there anything cool? I like the test tube. I'll just grab the boring one. There you go. Downloads. What is that named? Do I have my doc anywhere? Oh, it's here. This is test log. Okay. Oops. There we go. I'm gonna put it into as input shapes, and I want to make this terminal wider. I don't know why it made it so narrow. We'll do like transparent.png. So we'll make a test scene first of all to just get started here. Transparent. There we go. So make sure this actually is a transparent image. I think it is. Let me see here. I mean, there's no easy way for me to test right away. I think it is a transparent thing. I don't know. Let's hope it is. So let's make a test scene. We'll just make alpha JSON. There you go. Alright. I did not want to open that and texted it. Why did that happen? Let's just bring it up into Xcode here. Bring that over here. We're just gonna, yeah, we don't need to add it to a target. There we go. Okay. So let's get rid of some extra crap. We don't want any spheres or primitives in general. Let's just get rid of those. Okay. There we go. Yoink. No primitives for us. No need. Meshes, we'll keep the grid plane. We'll just, there are two options. We could just stick the texture in and not care about the aspect ratio, or we could make a new model, but I think we'll just do the easy way. Let's get rid of Venus scaled. I don't care about that. Bunny can go. Teapot. Yeah, most of these can go. Like that, I think. And apologies for the facial hair. I have not been outside for a while. I had a business trip and been staying inside. So yeah, this is kind of the situation. Okay, I think that looks good. Let's try and run that. Alpha.json. I think that's a good test settings. Okay, so there you go. Let's do like, what happened there? 10 samples. Okay, good. We have a test scene. Let's just stick the PNG in and see what we get. So grid plane dot material. We'll just I just clicked on them. I'm sorry about that. Oops. This escape key is not mapped the way I'm used to. There we go. Okay, that's good. Let's scale it down a bit. Do like 0.1. Okay, I think that's good. We see the E and the S. That's good enough for me. And I just realized that it is probably not. I think I got bamboozled with this PNG. That is a white PNG. Oh no. The one PNG that I took off DuckDuckGo is not a transparent PNG. Oh no. Let's check that out. Transparent. Is there an alpha channel? It's like an inspector. Right, RGB. RGBA. There's no alpha channel on it. Whoa. Okay, that's okay. I'm just not gonna say anything. Transparent. Let's grab another one, huh? Okay, that is not a transparent PNG. Which one might be? It actually shows. I don't know, man. Like, is there a way to make like the body? I'm not gonna do a styling to see if it's like transparent, but weird. Because here it shows it's being transparent. Maybe. Oh, actually, I'm completely wrong about this. Of course, it can have a white color with that just the alpha set. Yeah, okay. Maybe I shouldn't jump to conclusions so fast. Let's download this again. Okay. Okay, I think that's good. Wait, what? Rename. That's not what I want. Did it not download? It did. Ew, okay. Okay, why is it named like that? Yeah. Let's just check that out. Yeah, RGBA. I don't know why the inspector showed me that it didn't have an alpha channel. Okay, that's weird. I think I can do like, yeah, we can do like identify verbose and then this is image magic. It'll show us a bunch of stuff. Yeah, SRG, wait. Red, green, alpha. Okay, cool. So it's just weight color with the alpha. Okay. So if we run this stuff again, yeah, okay. Back on track, I think. Maybe I understand what's going on now. Cool. Let's rotate it a bit on the x-axis. So we'll do like 25 degrees, and that is the wrong way. Wait, that's really weird. Minus 25, so towards us. Oh, down. Don't do that. yeah, okay, yeah. And it's mirrored for reasons. Let's ignore that. So we have our test image. Now we want to make it so that this white stuff is actually transparent. Let's try and do that. So if we go to path trace, I looked at the code before this to find kind of a good place to do it. And we don't want to do it at the material level, because that's basically, yeah, we could start applying it to each material and kind of try and do that. But this needs to be a higher level thing. So basically what I want to happen. So if we consider this spot is going to be 100% transparent. So alpha channel is going to be at 0. So whatever color this is, we're going to ignore that. We're just going to go straight through. So we want to tell the rendering, the ray tracer, to basically just skip this and just move on and see if there's anything else. And the function that basically gets the closest intersection is called get closest intersection. And I think I'll initially do it here and then kind of see if there's a nicer place for it. But yeah, we'll try and do it here. And we're not gonna do it for polygons for now, because I mean, other objects cannot have a texture right now other than polygons. There's no like sphere texture mapping yet, so we're just gonna do it for polygons and see where we go. So the way it's gonna go is the ray is gonna hit the surface, and then it's gonna check out the color of it, so we get like the alpha channel. So and then it's gonna calculate the probability of going through. So since this is a multi-sample kind of thing anyway, so we're gonna fire multiple rays in the same direction multiple times anyway. So if we have like 50% like alpha 0.5, so 50% transparency, we basically want to go through half the time and then not go through half the time. So we're gonna involve the sampler here. So it's gonna be like a statistical thing. I think it's called, this is like Monte Carlo. And someone's calling me. Why is someone calling me? Let me pause this right. Alright, that was an urgent work call of all things at 10 o'clock at night. So I think it's dealt with, hopefully. We'll see if there's another interruption, but let's get back to this. So what I was doing was figuring out how to do this. So yeah, basically ray is going to hit that surface based on the alpha channel. We're going to either kind of go through and continue on or not. Basically, if there's a 50%, I think I said this already, 50% chance, then half the time it's going to hit it, half the time it's going to skip it. How would we skip this? First of all, we want the probability. We're going to grab that from the alpha channel. So we want to check if it has a texture and get it from there. There's no nice way to get just the color here. You have to kind of do this check, I think. So if like material has texture, yeah, if it has a texture, then we'll do, we're gonna need to, where is this? Yeah, UV, is this, it's static, okay. We're gonna make, this is kind of a hacky thing. We're just gonna temporarily expose this, see if this works. Put this here, and this basically returns a color for the UV coordinate that we have. So color for UV insects. Otherwise, it's just gonna be like material.alpha diffuse, I think. Alpha, there we go. And I think, yes. Is this actually what we use for the diffuse? Let's see, line version. That's like just that diffuse surface. Where's that? Line version. There we go. So diffuse color. Yeah. Yeah, cool. Yeah, we used diffuse. And so now we have that. And then for this one, alpha, I think. Oh, whoops. Okay, cool. So we have the probability. And if that probability is going to be like, so if alpha is 1, it's going to be fully opaque, right? So if the probability is anything less than 1, we're going to do this. And then we're going to need to sample that. So we're going to need to bring over our sampler, right? Yeah, so modify this just a tad bit. Where were we? Right here. then it's gonna complain. Same deal here. I don't know why I keep putting spaces, but anyway, sampler, cool. The sampler is basically our random number generator. Instead of being completely pseudo-random, it generates low discrepancy sequences, which is better for faster convergence. Maybe I'll touch on those later, but if get dimension sampler, this essentially gives us the random value between 0 and 1. So let's see if 100%, yeah, so it's going to be less than the probability. Then we want to skip this. How would we do that? I guess we can set the polygon to null, maybe. How do we check it here? Right, if exact inst index is less than 0. Okay, then we're gonna go. Yeah, we'll try that. Let's give that a go. Inst index is -1, and then we're gonna return exact. Cool. So now it gets the probability, and then if we hit it, so right now, right here on the black part, the alpha channel is going to be 1.0. So there's no way that this 0 to 1 number is going to be, no, this will always result to false. So it's just going to continue on. But if it's 0, then this is always going to be less than probability, and it's going to go here. So this essentially tells us that, yeah, we didn't find, this is kind of hacky, we'll find a better way for this, we're just going to skip it. And then up here is going to check for that. So we get the closest intersection. If the inst index is less than 0, we're basically just going to get the background color, which is like the HDR map or whatever you specify for that. This is not the correct way, but we'll roll with it for now. So let's see. Do I get notifications? Yes, I do get notifications. Oh man, they still want more info. I gotta get back to that, but we'll try this. See what happens. Okay, so nothing yet. I wonder if let's just hack the probability to be always like float prob is 8.5. Let's do that. See if anything happens. Oh, look at that. It's actually see-through. Check that out. And interestingly, it's kind of more see-through here because there's less of the white colors. 2 more samples. The more samples we get, the better it's going to look. Right. Okay, interesting. Maybe I have it flipped, actually. How does an alpha channel work? PNG. How does that work? I thought it was like 0 is like see-through and 1 is opaque. I thought that was how it works. Maybe? How do... PNG. Is there like a quick alpha channel? Alpha channel. Right. 0 to 1. A value of 0 means that the pixel is transparent and does not provide coverage information. No occlusion. Yes. Fully occluded. Yes, I got it right, I think. Maybe I'm just misinterpreting this image. It's kind of weird that the text is like almost fully transparent. Let's make it like 0.2. See what that makes it. It might be just the base color that's throwing me off here. Nope. Okay. Definitely got it wrong. How would that happen? So the text is see-through. I can see the maybe you can't tell in the video, but the background. Let's make this 10 samples. So I can see the background image through here, but not on the thing I expect it to be transparent. Why would that be? Is there like I gotta get back to the work thing, but let's just open this up and check real quick. It's really annoying that I have to deal with it, but it isn't like a quick one. Let me check the messages if it's urgent. Do they need my info? Quality content right here. Found the bug. Okay. Logs. Yeah, I gotta check that out. I'll be right back. Again. See ya. Alrighty. Just got the confirmation that it's not our system causing the issue. So, while I was checking that out, I pulled up GIMP, and it is indeed. The text is black. Test text is black, and the background is supposed to be white, or like transparent. So what's going on here? Why is this thing not... Okay. I don't know what this is. Let's close that. Why is this flipped? So the probability is 0.2f always, regardless of the color. So it's not even like it's flipped, it's just not. Okay, let's do 0.1. Could still be the color throwing us off here. But it's supposed to, it's not working, right? Let's see. Yeah, it's supposed to, yeah, okay. Okay, so probability 0.1f for any given polygon. What if happens if I run this on like statues.json? Will it be transparent? No? Okay. What's going on here then, huh? Got closest intersection. Sample unused, what do you mean? Of course it's used. So did I forget? No, I didn't forget to recompile. It's just not transparent. Okay, let's do 10 samples. Because these are supposed to be transparent now as well. And they're not. So every polygon with a... What is going on here? Okay, this is not working. Is this ever gonna hit? Wait. Okay, if probability is anything less than 1.0, we're gonna get here. Then this dimension, and we skip it. There's got to be a better way to do this skip, though. This setting the instance to -1 is kind of because then we're basically telling it that there's not going to be anything behind it ever. Just get the background color. We don't want to do that. We want to actually make this go through the thing. So basically, just continue on and see if there's anything behind it. So I think it's going to be a recursive call to this function, but I just want to get this basic thing working now. So we're going to ignore the actual alpha channel for now. Set the probability to 0.01. And yeah, so sampler. What if we just flip this? Recompile. And see what happens. Okay, now that's looking better. Why is it that way? Wait, so probability... Oh, right, because if probability is 0.1f, it's probably not going to be a random number. Yeah, okay, so I had it, that's the wrong way. Yeah, so probability, if it's 0.1, so 10% opaque. Yeah, I just had that the wrong way. Yeah, okay, cool. So yeah, now everything that's a polygon is now 0.1% opaque. And this is going to look better if I have more samples. So let's do like 100. This is going to be slow, but yeah, you can see it kind of works. Okay, so that's a proof of concept. That's what I want to do. So the reason why I originally wanted this is, so if you have like a tree, and then each leaf would be just like a rectangle. There's no point in modeling each leaf to be like super high polygon, with the edge shape and stuff. So the way, at least one model that I saw is just a rectangle, like a quad, with alpha channel texture on it. So that's why I want to get this working. I don't know where that model is right now, so I'll test that later, but I just want to get this feature working at least somewhat. So this is not correct yet. We got the idea down. Let's do the HDR now. Alpha touches. There we go. So now it's working. This is what I want to see. So probability 0.5. Let's now test if the actual alpha channel is working. It is not. It's just always okay. So we get the alpha. Okay. Let's set this up as a like a debugger thing. Do we have which this is debug? Okay. Maybe these schemes are all messed up. It's gonna be what was it, alpha? We're gonna do one thread so we don't get confused. And we'll see what we get. Let's play the lottery. We should get the plane, obviously, because we start in the center of the image, I think. Do we? That's configurable. Yeah, from middle. So it starts in the middle. And if we look at the image, obviously the middle of the image is going to be the plane. So this is going to be material. Yes, transparent PNG. So we hit the plane. We got the start direction, hit point and stuff, surface normal. Surface normal is wrong. I don't think it's set up yet. Hold on. Where did we get that? Shouldn't we have that already? Surface properties. That does not look right. Because it is tilted like... It's like if you're watching the plane, it's tilted like this towards you. So that is not the correct surface normal. Let's just ignore that for now. It shouldn't affect this effect. Okay. Yeah, so what does the probability end up being? So for this case, prob goes to 1. What happens if we do just dissect? Okay, all ones. That does not look right. Has texture is true. Really now? What our UVs are gonna be 0.35. Those look correct. So in terms of the middle of the image, it's gonna be white. That makes sense. But the alpha channel is wrong. This should be 0, I think, if GIMP is to be believed. So yeah, I think this is actually correct. It's all white, but I can find off like quickly. Do you have like pixelmator? Yeah, whatever. I just I couldn't find like an inspector to look at the color values, but yeah, this is wrong. So let's go look at that. Color for UV, and we use this is basically linear, yeah, bilinear interpolation. Flow precision. We get the things. Okay, so this is where we actually get the texture pixel. Let's actually step through that shit. So we'll rerun this. Step right in. Yes. Yes. Step in there. Yes. Texture get pixel. Cool. So inside X and Y, 1240 by 878. Let's just see what happens here. So if T has alpha, ooh, it does not have an alpha. Okay. So we're not setting the has alpha property, right? Okay. Load texture. This is where I found that my texture loader does not load texture from buffer. Right. Load file. Load texture from buffer. Okay. Load from memory. Okay, that looks good. Rec comp, I think, is like oh, look at that. Load texture from buffer. We give it 3 by default. Why is that? Okay, so we're just basically ignoring the alpha channel always. Always ignoring it. Okay, that's not right. What happens if I just stick a 4 in here? I don't. Maybe it'll work. Maybe. Maybe it'll break something else. So, okay, that does not look correct. I guess this is why I skipped it, right? Okay. So 3 works. But why? Is there a way to query? So I use STB image for this. Yeah, okay, so we're not loading alpha channel data at all, which is not good. Byte P is load from memory. Required compensation and the actual compensation ends up being new channels. And I don't know why it has this S has alpha thing. But what does this end up being? Let's just do this. So the oops. Y. Okay, whatever. Channels. Okay, it comes up as 4. So that's the I don't know what rec comp is. I think that's the required thing, like what we suggest it to be, maybe. But it ends up being 4, and this is not handled correctly. So I think we can just do it here. So new channels is greater than 3. New S alpha is true. Something like that. Maybe. Let's see if that works. And ignore. I guess we can set this to 4 now. Maybe. I honestly don't know what this rec comp is. See what that does. Ooh, look at that. And it works. Well, it's still hacky, but we'll make it less hacky. Look at that. Okay, so we now have alpha data. What about existing scenes? Like, let's do statues maybe. Does it still work? Okay, everything's kind of okay. Right, so yeah, basically if we so the statues are not using textures, so we're just setting them to a certain color, and I think I mean scaled. It's plastic and metal. We're setting that. It's not even in here, so it's just gonna be 0 by default. So how we set that? We'll ignore it for now. We'll deal with that later. Let's make this a little bit less hacky. So we're gonna continue with the alpha scene. So it's looking pretty good. But instead of doing the, I don't know what this is all about. I don't know if we can see that little garbage there. But, okay. We're now loading alpha data. That's good at least. I think that's a commit in itself. Let's undo this thing here and see if it actually breaks anything so I can make a commit. Let me build this and try and sit up straight so my back doesn't hurt. Yes, I don't think it breaks anything. Let's do like, yeah, 10 samples. This is a nice little demo scene of the instancing. There's only one mesh in the scene, but it's like transformed a bunch of times. So that looks good. What about like a classic scene? I don't think this will work. The old scene.c. It'll be a bit derpy, but yeah, it works. Okay, so I think we can actually make a commit of just I don't know what this. No, wrong project. So just make a little commit of the alpha data loading. So where's that? So here, yeah. I don't know how I didn't figure that out, but okay. Alpha channel. No, we can't load transparency. I think that's all we need for here, so we just pass it and then, okay, yeah. Is there anything else? Yeah, there's a bunch of crap from earlier, I think. At least some crap from earlier. Yeah, okay. Cool. Now these are relevant. So, right, okay. Commit that and throw that up. Let's continue with this. So, our hack. Why did that just bring back up? We don't want to do it this way. This is basically telling the, yeah, as I mentioned, if the instance index is less than 0, that's just the function telling us, yeah, we didn't hit anything, so we just get the ambient background, basically the HDR map usually. We don't want to do that. We just want to move on from this point. So let's try and come up with a way to do that. Let's see. So isect. What we will be doing, like, it's gonna look like. So we're gonna. The way we're gonna do this is we're gonna return get closest isect. It's gonna be the same. Well, we're gonna construct the new array. Well, we'll throw this in here for now. The same scene and the same sampler. We're gonna make a new array that's gonna start from that point and move on. So what should we call this? Like next, I don't know. We'll come up with a better name as we go. So it's gonna be incident array. This basically just gives the t component, so the depth, the distance of what we went through. This is one way to do it. So we're essentially going to go to the hit point. So when we get the hit point, this distance field is populated with the actual distance to that hit point from the array origin. So we'll use that, but we're gonna add like a delta to it, so it's not like, actually we'll not add a delta just yet. Oops, georeference like that. Wait, what is that saying? Next, why is this like that? I don't know. Okay, cool. This is gonna be next. And I just did my caps lock. Let's see. Yeah, okay, cool. Vector. Is this really? It returns a vector. Wait, what? Hold on. Oh, it's actually a point. Okay, yes, yeah, okay, next equals like 0 this out, and then next star is gonna be like that. Next dot direction is gonna be in the dot direction. Right, so we're just gonna copy the direction from the original array, so we're not gonna change the direction, we're just gonna keep going on in the same direction, but the start point will change. So we'll do it this way. We could also do like next next start is like hit point, but this way it's going to be harder for us to add a delta that we might want. But we'll actually try this and see what happens. What happens if we do this? Will this build? Next, oops, I don't know what we actually, why do we take a pointer? Start, array offset. So we do array offset right here, actually, right? So we actually, yeah. So from start, yeah, I think, yeah, this actually will take care of the, this is basically, I think it's called like the epsilon of, because if we just start from the hit point of like where we hit the polygon and start tracing array away from there, there's a chance that it'll hit the actual polygon again. So we add a little bit of just a tiny amount. I think the This is a scene global that we compute based on some heuristic. A tiny little float value, and we just move the hit point just a little bit off the surface, and this does that. So we actually, yeah, we can use a existing hit point. We don't need to do this calculation because this is like it's a bit of math. Yeah, vector addition, vector scale, multiplication. Yeah, so you can skip that. We'll actually do it this way, and that's a semicolon. You dummy. This is an older compiler that complains about that. We're just not going to compare. We'll just do that. Let's see what this does. We want to... Hold on. Use the right one and recompile. Ooh, that's cool. See that? You can see the test text again, but flipped and again. Why is that? Oh, wait, hold on. See, it's actually projecting again because in this case we are this is an instancing bug. So let's see, transform point, hit point. Think we need to do this after this one. So you go back to world space, I think. So we're transforming the hit point surface normal back to world space, I think. Or the other way around, I forget. Let's do it after. Let's see. Let's move this down a bit. This might fix it. This is just a hunch at this point. We'll just do a crappy code here. Polygon. Yeah. We'll check again if it's a polygon. Do it here. Right. See if that fixes that. Whoa. Oh, that's cool. Look at that. A sig bus misaligned addresser. How often do you see that anymore? I mean, 99.9% of the crashes I get are just seg faults, but that, okay. I don't actually know what a misaligned address, but I mean, it's a misaligned address. What happened here? That's cool. Oh, okay. Yeah, so we blew the stack, I think. Maybe. Yeah. We blew the stack. That was predictable. We don't want to send that to Apple. They don't need to see that. Yeah, right. Of course. Recursive call to get closest thing. So if it's a polygon, okay. How do we stop the recursion here then? We'll just do like a boolean so we only go one out, so we'll stop. We'll do it this way for now. We'll see. Right. And see what happens here. Okay, so that's something. It's kind of better, but also worse. So we don't see that weird projection thing anymore, but we do see this kind of artifact. What happens if we just up samples down about like 100 samples? See what that looks like. It's like a ghost kind of surface. Okay, so that's not correct. I'm sorry, I keep touching the microphone. Hopefully it's not that noisy. This whole stop after one is really annoying. Let's not do that. Okay, so we get this interesting image. Let's keep doing it. I didn't change anything. Why would it? Okay, anyway. Here's our little test image. What is going on there? Let's see what happens. So let's see. It hits that surface. It's gonna go into the same direction. What happens if we like change the offset? Do you like that? Okay, it went away. Okay, so our offset's not. Yeah, that's an epsilon bug. Okay, so that works. Now, yeah. So the way the scene offset is computed is think yeah. So this is a really crappy implementation at the moment. We basically the way I was told it should be done is you take the root bounding box of the entire scene. So the basically the bounding box that is the minimum size to contain everything in the scene, and you take the diagonal length of it, and then that's your array epsilon. Then you multiply it by some coefficient. This I just pulled out of my ass. Evidently, it is not correct for this scene. There's the idea with computing it from the diagonal is that you don't have to fiddle with it between scenes. So some scenes are like huge, like a canyon or something. Some scenes are tiny if you're doing like, I don't know, a test scene. This is really small. The way I usually think of it is like, so if we look at the JSON here, the units that I use can be thought of as meters. So in this case, we move the camera backwards 0.7 meters on the z-axis, so back this way, and then up by 0.1 meters. And then this grid plane, however big that is, we scale it down by this factor. This is not meters, this is just a scaling factor. Then we rotate it by 25 degrees. There's no real good scale here, but it's not that big. I still have to fiddle with that value, which tells you that this is not working as well as I hope it would. Let's actually see what that turns out to be. I'm curious. I'll diagonal get root bounding box for our scene top level. So the bounding boxes are like this hierarchical kind of thing. So everything's like hierarchically in bounding boxes. So if there's like a room, that's like a bounding box basically, and then inside the room there's like chairs, and then the chair has bounding boxes. I'll get to that later maybe, but in this case we're just getting the diagonal. Yeah, I guess the plane ends up being about 1 meter on the diagonal. It's infinitely thin, so basically we're just checking the diagonal of the plane here. Yeah, we're gonna ignore that and just have the epsilon be different by kind of a random amount for now. That's a different issue that I need to fix. See if that worked. Yeah, okay. So there, yeah, that wasn't that issue wasn't caused by this feature. So the reason why I moved it below this, basically when we start traversing the BVH and find the right instance to intersect, before we intersect that, we transform into the local space for that instance, intersect it, and then we need to transform the actual hit point we find at the surface normal back to world space so we can start going off somewhere else. So I forgot to put it after this. So yeah, this is very much a prototype. I don't know if we are actually gonna make something that's good enough tonight. We'll see. I've been interrupted twice, so we'll hope that nothing else blows up. I shouldn't check my phone, but yeah, no more messages. So I think we're fine. Okay, so this works. Let's make the plane a bit smaller. We can do that from here. Let's make it like real small, so you can see the whole thing. Okay, maybe not that small. There you go. Okay, there's still a little bit of artifacting here. but you can sort of see it. Let's if we don't rotate it at all, it's like flat. Let's do 90 degrees. See if that works. Yeah, there you go. Cool. So that is not a model. That is a single. Well, in my render, I don't do quads at the moment. I just do polygons. So it's two polygons, two triangles stitched together to make a rectangle with that. Okay, I'm gonna save that image actually. That's like pretty good. And how is it not flipped? Do I flip? The thing is that my coordinate system for C-Ray is like off. So I thought there was like a code, some code to like flip textures and stuff. But maybe there isn't anymore. Maybe I fixed the bug. I used to have to always like flip textures to make them fit, but apparently not anymore. So when I hit like a semi kind of milestone, I usually save these images. Out to put first working no. So just for later reference when I got this working basically. Cool. Okay, so there's our image. Let's just make sure that everything works fine. See what happens here. And we'll do like 100 samples. No, let's do, whoa, actually 10 samples. Yeah, so you can see that there are some issues. My benchmark for putting something up or not putting something up is usually does it bake existing scenes in here? It obviously does. So the plane thing is working nicely, but for existing meshes, it's not too hot here. So it is trying to go into this statue and see if it finds another intersection. How would we deal with that? Let me think. This is where it gets annoying because then we have to have another edge case to check if it's like an actual like mesh with depth, because this kind of assumes that it does not have any volume, and there's no code for like, maybe I'm thinking this wrong, but there's no code for like checking if a thing has volume, because it's kind of good for like well, I mean, this should work for every case. Yeah, let's not think that way. This should work for the statue as well. How do we make it work for the statue as well? Let's not get out of here without a little bit of thinking. So this is not a ray offset thing. That is definitely a bug caused by them. Well, maybe it's not. Let's check. Just making sure it's not the ray offset thing. Yeah, it's not the ray offset. It is definitely the okay. There's an interesting problem, which makes you think: is this the right place to do this? So at this point, we get the intersection. Have texture. We could just do it only for textured meshes, but that's kind of a workaround for now, because I mean, this statue could, for all we know, have a texture. How do we want to do this? I wonder what the correct way for doing this is. There's probably a paper discussing this, but let's try and come up with something. So this approach sort of works. Now I kind of want to make it so that this plane has like half transparency, so it's like 50%, but I don't know. I also kind of want to You know what? Let's make a test image. Is there a way to this is where I try to use GIMP. It's not gonna work. So it's gonna be how do we get up a directory? No. I don't know how would I go back? Why is there no? That's weird. Input shapes grid. Let's make semi-transparent version of the grid. And now how do I adjust it? Color, no. Colors. Channel mixer. Color to alpha. No, I don't think I want that. How do I do this? I'm gonna Google it in about 10 seconds. I just never really used GIMP that much. Yeah, I'm gonna Google it. Seems like everything I want to do with GIMP, I just gotta Google it. GIMP set image transparency. Open image, select area. Okay. Why is this? Is it layer? Okay. Layer. There is an alpha channel, but how do I? What pictures? Ooh, WikiHow. How do I do this? GIMP. Yes, yes. Layers. Yes. Yes. Then we lower the opacity value. Top of the window to the left. Oh, right. Obviously. 50%. Let's do like that. Right. Then export that. That was easier than, yeah. So grid. Transparent. I think that's good. Jeez, worth interlacing background color gamma. I think that's good. Export. No, yeah, Discord changes. Okay. Grid plane. It's gonna be. I think it's. I think I need grid. Whoops. Oh, I keep hitting my. I usually have my caps lock key set to desk, so. Maybe that'll work. Yeah. So now it's like 50% see-through. Okay, cool. But what about alpha? Yeah, there we go. That's what I was looking for. Cool. Neat. Let's do like 100 samples of that while we think about how to actually do this properly. So right now, it's just the hack, the thing that we implemented. But then again, this whole project's a hack. Trying not to drop my laptop. Okay, that works. What do we want to do here? Stop is not a good thing to use. Let me think. How do we do this? We want to probably put right, so we only go through if it's transparent. Then we do the offset based on the hold on. The direction is going to be out that way. The offset and the start point. And then we're gonna, yeah, it's smoother. Get the dimension and compute the next ray. And just use that. I don't like the soul stop thing. Let's just get rid of that for now, at least. Don't like that at all. Derpy code. Let's not do that. Cool. What happens if we just run it? Will it blow the stack? It does not. Okay. But for another scene, I bet it will. Okay, it doesn't. Okay. Cool. Maybe that whole hack was unnecessary? I don't know why it did the whole... It might not have blown the stack. I don't know. Because, yeah, it actually doesn't make sense for it to... Because it's going to go through. Why would it recurse infinitely? Is there a case where this could recurse infinitely? Get closest intersect if it's a polygon. No, there is no way. Unless it self-intersects. In which case, it might. Let's go check that out. It might have been the self-intersection case. So, like this. Okay. I don't know what happened. I think I fixed the thing. Okay. Let's just keep that for now. Scene. 10 samples of scene.c. Ooh, there you go. There's our misaligned address. Okay, so let's see what happened here. We can't have that. Whoa, that's not what I wanted. Now we're gonna run with one thread and see what happens. Right. At this point, it didn't crash notably, but at this point I want to basically so the mesh loader uses a bunch of really old code that I have not touched for a really long time. That uses like a weird opt loader thing that I need to phase out. So add the materials to mesh, right? Material from opt. Okay, so yeah, we're just gonna set the alphas here to 1 for now. So we're gonna always assume. So now we're actually processing that data for the first time. We've never actually handled the alpha before. This is like really old code, by the way. just throwing that out there. Don't judge. Let's see what happens here. Will it still crash? It's not nice that there's like an edge case somewhere triggered based on the color value that actually has like a misaligned address error. That's really not common, is it? Yeah. What is a misaligned address error? Right. 30-bit aligned. Yes, that makes sense. It could just be that it's not. It is a SIG bus, but it just might not be like a misaligned address. It could just be some other memory error. I don't remember the last time I saw that issue. Set up straight again. I keep slouching. Okay, so existing scenes are unaffected, which is good. Statues, how about that? Right. Grid plane is, wait, is it transparent? I can't tell. I guess it is. Yeah, it's transparent. Okay. So there's our slightly transparent grid plane, and then we can make it not transparent. Right, so let's see. I think this might be shaping up to something that we can commit, but I don't know. I'll have to debate that with myself. I keep hitting the fucking caps lock. Again. Ooh, that would not. Okay, yeah. Cool. It is slightly different. It's kind of hard to see the difference here, but you'll see when this image refreshes, you'll see what the difference is. I can tell that it's different. It's not a very good test image. I'm pretty bad at doing test scenes, but it's just enough for me. At least we got some code written tonight. It's been a while since I worked on C-Ray. It's good to I took a break from this project. I started working on some other stuff. I got an ancient Mac Plus next to me here. I don't want to grab the camera. I just can show you the mouse that I've been working on, writing some code for. So there might be a video idea there. Haven't come up with a good idea for what I want to code for it, but we'll find that out. Okay, so this is kind of working. Let me look at the code and see if I think it's ugly, and if it's ugly, we're not going to commit it. It's kind of ugly. See, the thing is, this is the only point where I think this makes sense. And now, right now, we have this exception. We only do it for if it's a polygon. I don't think we need this check here. I think we can just yoink it out. Maybe. So, see, we compute the probability. If it doesn't have a texture, it's just going to be alpha 1.0 anyway. So, we're going to just skip this. I think that's fine. Yeah. What about like, well, yeah, we don't need to do that polygon check. We'll do it for everything. And there are no material overrides that are good and usable at the moment, so I'm not gonna be able to check for like solid material ones. What happens if I do set like, hold on, let's set the trans, hold on, like let's set the diffuse alpha 2.5 for all solid color meshes and see if it crashes. I think it'll crash, maybe. Yeah, see that? Ooh, that's actually kind of cool. Look at that. Neat. So we're not doing the... It was not. I don't think it's stack, blowing the stack. That was just a hunch, but that's actually cool. Let me move that. Cool. I'll just number them like this, so I can find them alphabetically in a group. What about statues? Yeah, that's gonna look cool. I'm just stress testing it and debating if I want to commit this. The whole material system is gonna have to go. It's gonna have to be redone completely, and I don't want to build. No thanks. Same for the mesh loader. I like that. That is looking cool. Actually, let me do a bit more samples. 100 samples. So let's gonna let that bake over there and look at the code. So this works. It kind of works. I've been thinking of a good way to do this for a long time, and it's just kind of hit me that I can just basically just keep going after it. This would be an awesome time to have that tree model. Do I have something like that? Maybe. Do I have something on my laptop? I'm pretty sure sure I had like a really nice tree model with textures and everything. Grab my laptop here. Well, I'm a programmer, so there's going to be a lot of stuff about trees in the programming context on my system, but no tree models. Let me bring this up so I can see it. Baking there, it looks pretty neat. Let me look on the thing. What was that actually? Yeah. So. Do I have anything called a tree? I had a model. Shapes. I don't see one. Tree, hey, look at that. I actually have a entire tree directory. Hey, look at that. I actually have a, yeah, I have a scene. I might be able to test. Let me compress this. Does this actually? Yeah, look at that. Actually, yes, that's great. I got the teapots, and then I have a tree, I think. Do I? Yes. Cool. Let's so I'm on my laptop right now, and I'm not gonna SSH into from here. Basically, I have this scripts bundled.py that I made in January that takes a scene JSON and compresses all the assets and the JSON to one zip file. So I'm gonna do that. Hopefully it works. Scripts bundle.py input tree.json. So it's compressing all the assets, and then I'm going to SCP this over. So let's see here. ASFG. Okay. Hopefully I get the path right. Was it ASFG? Will it show up? Exciting. Oh. Oh, I need the dot slash. There we go. We got the file. Transferring 11 megs. Okay, cool. Laptop go away. I just totally hit the thing on the table. Okay. So, whoa. I dropped the thing. Okay. So, okay. Hopefully this will work. Make sorry. It's gonna be tree. Where did it actually put it into? Tree.json. Okay. Wait. Where did it put it into? Tree.json. I guess it's just merged into. Okay. Yeah. See if that works. Running 2 instances of C-Ray at once, this machine is going to get slammed. Hey, it actually loaded. Ooh, maybe we'll get to see something cool. Maybe we'll get to see some leaves. We can do a before and after comparison. Maybe. I don't know what I'm looking at. Let me set the samples to like 10 so we can get a closer look here. Look-see. Ooh. What is that? Okay. I'm not sure what I'm looking at. What is that? Hold on, let me think. What? Oh. That's like a different scene. Hold on, let me it's gonna be we're gonna make a directory for this because it like merged with some different scene from this script needs work, I think. Unzip 3. Right. Cool. Okay, so let me modify these. Okay, I actually got this one ready. So here we go. Let's move this one. 2. Save that. So we got some nice transparent-ish kind of statues. That's cool. Let's get back to this. So Vim tree shapes grid plane metal earlier experiments. We'll do this one. Oops. And tree.json. Did it load? It did not load the oh, actually I've wait. Oh no, you know what? I might have messed that up. See on the original file. Whoa. I don't know what that was all about. I'm just kind of messing around at this point. If you don't, I'm not programming anymore. Oh, C obj D. It didn't find the file. Crap. Okay, let me redo that zip file. Yeah, so it didn't even compress the tree file. Okay. Okay. That's something. Okay, let me just move this over. Yeah, so now we actually have the assets. Yeah. Okay. I was wondering why it was so small. 11 megs. It's a pretty big model. So I'm just yeah, compressing the thing. So the script is actually pretty cool. It'll look at the JSON and look at all the assets that it can find in there, and then it'll so if it finds an object, it'll look inside that object for matrilib files, which are the wavefront material files, and then it'll look for textures in those files, and then bundle it all up and preserve the structure that you had. So it should work on any system. Okay. Cool. So it looks like it now put the actual mesh. And now it's an 84 meg archive. So okay, cool. So SCP-3. Let me just subscript that thing. Copy that one over. Move the path and replace the file. Okay. Cool. Okay, transferring. So let us what is it? 35, 30. That one. Oh, tree. picture tree, and then it is transferred. So zip d tree. There you go. Okay, cool. Now we should be in business. And since it's using those assets, do this again. Okay. Make sure we got the latest one. Tree.json. Okay, so I was looking for these weird. Oh, we're not handling all the material properties in the wavefront thing because I didn't find grid.pn. That's because I mistyped it. What? How did it not find grid.pn? Tree shapes. I guess it's cut off there. I'll just copy it over. Yeah, okay. Oh, wait, we don't. I'm getting a bit tired. So yeah, I don't know why it's cut off there. I gotta fix that bug. But alas, it shall render, and we will put this. How many samples is that? 250. We'll do 110. Loading assets. You can look at these cool images while it's doing that. Ooh, okay, that's not working the way I expect it to. Okay, so there's the tree, right? We want to try and make that work. So why is it doing that? First of all, let's undo this thing. Okay. And recompile. So let's look at the assets. So here we got the tree bark and stuff, the leaf, bark, and okay, so all the leaves use the leaf texture. Is this actually a transparent texture? Hard to tell. Let's open it in GIMP. See what it thinks. Open. Yeah, again, not really useful here. Tree leaf. Yeah, so it is not a transparent file. Why is that not transparent? Does it not even have a... Yeah, it's not transparent. Okay, so it's not actually probably my program. It's just for some reason, maybe there's like a special case where white is considered, but we're just gonna make it transparent. How do I do this? I guess I'm just gonna cut it off with like a magic tool or something. Jeez. Oh no, GIMP. How do I... Okay, we're just gonna make a... Okay, fill by... And we're gonna set the color to be completely transparent. How do I set the opacity? God, I don't like GIMP. I just don't really understand it. The whole... Okay. Google time. I'm not gonna mess around with that. Make a background transparent. Thank you. Just gonna Google that on Bing DuckDuckGo. Right, so we have to make a selection and then... Fuck. How do we... background of an image transparent. Yes. Shadows. Yes. Levels of the image. Magic wand tool. So the magic wand tool looks like a magic wand. Yeah, so this allows us to select the thing, right? So now we have the whole thing selected. then yes, cutting out the use colors, color to alpha, colors, color to alpha, color to alpha. It's not available. It's the one option not available. Okay, so apparently, okay, we just cut it, maybe. To a new layer, maybe, and then delete it. No, colors. Why can I not do colors alpha here? Why? New layer from visible. No. I want to cut it. God, why would bucket fill with the color erase mode? Bucket fill. God, these icons are identical looking. Maybe I'm just blind. Where the heck is the bucket tool? There you go. Mode. What was it? Color erase mode. This fucking tool, man. I'm clicking. Nothing happens. How do I... Can I move this? Like, I just want to cut it, please. Is there an edge detect tool? How do I just make the... I don't understand how to use this program. Why can I not just fucking get rid of the thing? God. Why is this so hard? Like, why is this not easy? Why do you disable this option? Now I'm getting frustrated. Why do you disable this option? Why? Magic one selection tool. Let's select the whole thing and then call it the alpha. Why? Okay, let's add a color channel first of all. I think it was here maybe. Add an alpha channel. That is why. Okay, I'm getting this. Okay, so we select the whole thing. Not that far, just roughly. Okay, there we go. Then color to alpha. Boom. Got it. Cool. Okay, and then we're gonna overwrite the file and quit. Discard changes and re-render. That's the other terminal, wasn't it? See what that looks like. So I'm glad it wasn't C-Ray's fault that it was actually not part. Ooh, let us move the tree over slightly. We're gonna move it. I don't know what's going on here. We're gonna ignore that. But look at that, it's a tree. That is why I wanted it originally. Let's open tree on this one. So translate. We're gonna do this to 0. Hit the thing again. What else do we want? We want to set the V of the camera to like 15. See what that looks like. You can see the leaves a bit better. If I get this rendered nicely, I think that's where I'll end tonight. Ooh, look at that. You gotta up the samples. Let me get rid of the... I'm sorry I keep teasing you. I just want to make this right. So Venus... Disable that one. Bunny. I just add a D to the end. That's it. It is a pretty big model, isn't it? The actual tree is 309 megs. Again, I don't know what is going. I think that's a sphere actually. Why are they so... Let's see. Now I gotta find that out. Parse sphere. So we make the material somehow differently. Radius. How do we get the color? Last instance, add sphere. Maybe it happens here? No. Where is that thing? Plastic. Color. Color, get object ID. Okay, emission, parse color. And alpha is not specified, so it defaults to 0. It should default to 1, honestly. I think, at least. I think that makes more sense, because it's just, if it's invisible, it's gonna be confusing to the user. Who's me. It just confused me, so that's why I'd change it. Okay, cool. So let's get rid of the spheres now. I don't actually want to see them. Is there, like, there's a way to specify the app? Tree. There we go. Oops, that's not them. Let's get rid of all the primitives. I don't want any primitives here. There you go. Let's rerun this. Just gonna make a nice little final image here. 304 megs, Venus scaled. Yeah. Let's get rid of those actually. While it is rendering up here, I will get rid of them. You can see how fast it goes outside of the tree. That is looking great. Okay. No fancy stuff like the leaves aren't. I could make the leaves semi-transparent, but it's not going to be realistic. So we're gonna get rid of Venus scaled, bunny, teapot. I just don't care about these right now. Bunny. It's already disabled. Cool. Okay, that's gonna be cool. Look at that, it is an actual tree. The teapot's still there, but whatever. I think the teapot is actually kind of fitting, I feel like, for a test render. You know? We'll keep the teapot. Get rid of the Venus stuff and done. There we go. Okay. Now we'll do some more samples. Make sure we got the latest version. How many samples should we do? I'll do like 250, and while that's rendering, we will clean up the code and figure that stuff out. So I'm gonna put this up here. Can I scale this? I think I can. Maybe slightly bit small. Oh. Okay, so there you go. It's rendering over there. Let's see. Check out what changes we made. And what is this? Okay, relevant. Okay, so we're gonna split this into a couple commits. So no alpha this default it to 1.0 instead of 0. It's a bit confusing. An object just disappears if you just specify color. Yeah, that's a good one. That's gonna be a cool render, because the first time I rendered this like a couple months ago, I was like, geez, how do I get the leaves to look right? And now they work, so that is cool. Neat. This is a different change, the converter thing. Yeah. Out to alpha 1.04. Process the alpha channel. Is there anything associated with this? Not really. for middle. Cool. Yeah. How do these changes look? So we are borrowing the color for UV to get the alpha. Should we make a function to just get the alpha? I don't know. I don't think that makes much sense. Let's see. So, color for UV does a bunch of stuff, but it's gonna do this anyway. Yeah, there's no point in just making a special case. We'll use this one for now. And this is going to compute every single time we want to get a closest intersection. Is there a case where we can eliminate this? Not really. I mean, we do want to query if we want to do this only if it has alpha at all, or like the alpha is less than 1.0. Okay. Yeah, we'll just make the next ray start hit point. Is there a way to make this a little bit nicer? This is gonna be SX hit point and this we can do like that. Is it that way? Start direction ray type. Ray type. Still gonna be incident. I don't know if this ray type is even used anywhere. We should check. It's still kind of incident. But is that used anywhere? It's set. I know that. Yeah, we set it there. We set it there. And all the materials basically set. If it's like a scattered ray or a reflected ray, but it's not actually used for anything, I don't think. So it doesn't matter that much. Yeah, it's not used. Should remove that. Okay, but I think we're almost close to wrapping up here. Look at that. Doesn't that look kind of cool? It actually kind of looks like a tree. That's nifty. The BBHs took 3.46 seconds. In this case, I think, yeah, the whole thing is just a single object file. So there's just a single BBH in the scene, which is probably not optimal. Actually, for this case, it might be. Yeah, I don't see why that would hurt. Let's commit this. Yeah, that's gonna take a little while. And yeah, the resolution is kind of low as well, but you can see what's going on. Do I want to commit this? Am I happy with this code? Or do I hate it? It's a little bit of an addition to the get closest dissect. I don't like giving it too much responsibilities. I don't really like putting this here, but I can't think of another place where it would fit at all. Traverse the thing, because we can't put it into the material system. That's already like ugly as fuck anyway. I think this is the place for now, at least. I mean, I can just move it later if I find a better place, but I'll leave it here for now. I think that's good. Fairly simple, not too inelegant. So we just, yeah, we'll literally just keep going in the same direction. The offset's already handled for us, so a couple lines of code. That's kind of what this project is. I work for 2 hours and get like, 7 lines of meaningful code here. That's our thing for tonight. A little bit of extra stuff to do and like set up, but look at that. We actually have leaves with transparency. It actually looks way better than I anticipated. Like there's no glitches that I can see. Let me make this a bit bigger. Well, that doesn't really help because it's still like, low res, but you can sort of see it. I think I'll commit this. I'm gonna throw it in. I'm not too worried about, you know, putting kind of worse code in there, at least temporarily. Yeah, we just pass in the sampler into get closest exact, because now it does Monte Carlo, you know, kind of sampling as well. And yeah, I'll literally just use dimension for that. Okay, I think I'm happy with that. It's gonna look like crap at like 1 or 2 samples, because well, actually, that depends on the transparency. If it's 50%, then it's gonna look like crap for the first few samples. So it's gonna be pretty noisy. But for stuff like this, where it's literally just like, yeah, it's transparent, 100% transparent, it's not gonna be noisy. There's probably a much better way to do this, but I'm happy with what I'm seeing right now. So I'm gonna roll with this. Let's commit this. Yeah, literally just get closest exact, making sure there are no derpy code here. Yes, we adjust the ray offset here, which now kind of sneak it in this commit as well, even though it's not directly relevant. Expose that one. Yes. This is unrelated. This is unrelated. Unrelated. I feel like making like a test scene as well. Do I want to make one? No, because we would have to include like a texture with alpha, so we're not gonna do a test scene. You're just gonna have to try it out for yourself. Link in the description. Go and get the source code, play around with it. Oh yeah, smash that subscribe button, of course. Yes. I got some weird flags testing here. Yeah. Cool. Good once over. Is Monte Carlo the right term? Let's not use too fancy terms here. Simple alpha channel transparency implementation. Just it does a probability thing. I'm bad at these fancy kind of math words. How do I tell this in a nice way? It does a uses the alpha channel as a probability to determine if it should pass through the surface or not. Sort of a multi-sample implementation of alpha mixing a path trace. Okay, let's not go too far. So add a simple alpha channel transparency implementation. I should say for textures. It works for everything. It's just not really available to most things. If you load up, if you make a t-pol, let me see. How do we? Yeah, we just get the color. There's no way to override materials, for instances, at the moment. So we just get the color directly from the input file. But if we do like if we do a sphere, then you actually give the color here in the config file. So that's why I have to fix the assumption. If defaulting to 0, so it defaults to 1. Look at that render. That's pretty cool. I don't see any obvious glitches. And that's good enough for me. Okay. I think that's good enough. I think that is it for tonight. We're gonna take a look at the image rendering here. Let's see, C-Ray. Pushed. Okay. Hopefully I didn't break the build for Windows. Now I kind of want to add this image as like a demo, but maybe not. I might do like a new version of the HDR scene with like a tree in it. But these scenes are both, well, this scene is available in the repository. You can just directly load up the hdr.json in the input directory. But this one is not in the repository because it's got more assets. I don't want to put big assets in the repository. The statue is already pretty big, and that was like an early mistake. But yeah, I think that is it for tonight. You can sort of see the results. It's going to take too long to render. I'm not going to draw this out any further. We've been at this for like almost 2 hours now. So if you got this far, I really appreciate it. Thank you very much for watching this. If you're interested in this stuff, if you have a friend who might be interested, go ahead and share if you want to. But yeah, I think that's it for tonight. So we get to enjoy the tree. So yeah, I think I'm done. So good night.